board. All right, so this is homework 2-1, number 4. So I'm given a universe. So universe would be drawing a big box around this. Box is not quite a box, but at least it's got 4 sides. All right. And so I got to start placing these things in here to try and analyze what this set down here means. And it could be we could do it without a Venn diagram, but I find Venn diagrams nice ways to do things. So what I find is when I work with a Venn diagram with 3 sets, the easiest thing to do first is the intersection of all 3 sets. So I look up here and say, okay, what do all 3 sets have in common? Let's see, they don't have an A in common. They don't all have a B in common. They don't all have a C in common. They don't all have a D. They don't have an E. Oop, they got an F in common. And they don't have an I. So it looks like on my version, the only thing they have in common is an F. So you could try my version with me. Even if you already did this, this is good practice. All right, so I got F there. So then from there, I move up to just focusing on 2 sets. Okay, what do A and B have in common? Now I've already marked off F. What else do they have in common? For me, it looks like just an I. A and B is not up there. So then they would have I and F in common. F also being in common with C, so it just goes right there. So then otherwise, I move on to the next pair, like say A and C. So I already got the F. They have an A in common. They have a B in common. Oop, B, sorry, I was thinking ahead there. Let's try that again. There we go. They don't have a C and they don't have an I. So it looks like A, B, and F are the common things there. And then I'll move over to A, B. No, sorry, what is this? B, C down here. So B, oh, I just did the wrong one. I just did B, C is what I was thinking. Okay, so let me try that again. A, B goes there. Okay, I want AC, which is, okay, make a note to myself, I'm comparing these 2. All right, so I've got the F. Otherwise, what do we have? We have an E, A and C, an E in common. Oh, they have a bunch in common, G and H. All right, so let's double check. A, no. B, no. C, no. E, yes. F, yes. G, yes. H, yes. Okay, so E, F, G, H. E, F, G, H. Okay, got it. So I have the intersection of all 2. I have the intersection in pairs. By the way, let me just make this clear. If I wanted to list the things that are an A intersect B intersect C, so what do all 3 sets have in common? That's a new set, and that set only has F in it. So that would be this right here. If I then wanted to say, note, what does A and B have in common? A and B have in common I, and they have F in common. Okay, F is in the intersection of all 3. F is also in the intersection of just A and B. Does everyone get what I'm saying here? Let me do that one more time. What if we looked at A intersect C? So what do A and C have in common? That would be this crescent over here. A and C have in common E, F, G, H. So when we talk about the intersection, that's the full overlap of whatever sets I've listed. Right, so the intersection of A and C is everything in this region right there. Whereas the intersection of all 3 is just that spot right there. I'll do some of this. If I just wanted to describe, say, this part right over here, here's what that would look like. So I'm on a slight tangent, but that would be A intersect C, right? Because I definitely have this stuff, but I don't want all 3 of them. So basically I would say, give me A, C, as long as it's not in B. And the way you do that is intersect, B complement. So give me what A and C have together, and as long as it's not in B. And that's what the C says, as long as it's not in B. So that right there would just be that E, G, and H. We'll do another one like that later. But it kind of relates to what I see down here. So any questions on at least the first 3 sets I listed there versus what I see in the Venn diagram? Okay, I see no questions popping up. Is anybody still with me? Okay, good, thank you. All right, there's a human too. Thumbs up and a human, good. All right, so finishing this right here, I start on the inside, work my way out, so maybe I'll finish off set A. Did I miss anything in set A? Well, let's see, I didn't write down D yet. And then I've got E, F, G, H, and I. Okay, so that completes set A. Moving over to set B here, B has A, B, F, and I, but B has nothing else to consider that's not already in A or C. So I've got B covered. And then C here, let's see, I've got A, B. I don't have little c yet. Let's see, A, B, C. I've got E, F, G, and H. Okay, so I think I've got it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's just a Venn diagram is just a different way, a visual way to organize information. All right, so let's see, is that everything in the universe? Do we have all of A, B, C? So now I'm looking up here at the top. Do I have everything there? So let's go, let's see, A, B, C, D, E, F, G, H, I. A, B, C, D, E, F, G, H, I. All right, so it turns out everything in the universe is in A, B, or C. There's nothing outside of those 3 sets. Good to know. All right, so now let's see if we can figure this out right here. So maybe I'll start with a highlighter. So this says find the intersection of A and C down there, and then take the opposite of it. Okay, so A and C meet right here, but I want to take everything outside of that. So I'm just going to do this to get everything outside of that. So I'm trying to highlight everything outside. All right, so that's everything outside of A intersects C. Then I want to find, let's use a different color. Come here, pen. B intersect A. So let's see. B intersect A is up here. So this right here is B intersect A. And I want the complement of that, so everything outside of that. Maybe I'll do that a little bit different. We'll go like diagonally like that. So I want to somehow denote on my picture everything outside. All right, so I shaded that. Next thing I need to consider is, what is the union? So union means take this and just throw them together. So next thing I want is everything that has some yellow shading or some green shading in my picture here. All right, so let me see here. Everything that has some yellow or some green. So I'm going to use blue to mangle the picture some further. So like everything out here is yellow and green, but there's nothing really out there in the universe. Everything here is yellow and green. Where does yellow and or green not happen? Some of that blue, that's making it worse. All right, so let me go over what I'm thinking here. So the union means or, so I'm looking for the yellow shading, yellow highlights, or green highlights is what I want here. And I know I'm misspelling highlight painfully, but sorry about that. I'm running out of room. I think this place right here is the only place where the F is the only place that's missing yellow or green. Right? This region right here has green but not yellow. This one right here has yellow but not green. Everywhere else has yellow and green, but just there is missing it. Okay, so here's what I think from that shading for the answer to my question. Let's do this. I guess we can do it in blue. I think this is everything but the F. So it would be A, B, C, D, E, F. No, not the F. E, skip F, G, H, I. All right, I'm going to do this another way just to double check. I'm going to, in red, write down each of these sets right here. So what is A intersects C complement? What's in that? So this is A intersects C right here. I want everything outside of that. Okay, so everything outside of that crescent, that football type shape, would be the D, the I, the A, the B, and the C. So I just started here and went around. D, I, A, B, C is everything outside of that shape right there. And then let's do the next one. The next one would be what is B intersect A complement? So that means first find B intersect A, so that's right here, and then look at everything outside of that. So I want everything except I and F. Okay, so starting, let's see over here with the D again, I want D, then A, B, and C, and then E, G, H. So sometimes we have to do things in pieces. Next thing I want to do is take those two sets and say, what's their union? What happens if you put those together? Okay, well, if I put those together, let's go in alphabetical order. There's an A in there. There's a B in there. There's a C in there. There's a D in there. There's an E there. I do not see F. There's a G. There's an H. And there's an I. Did I get the same way, same thing I got down here? Looks like it. Ooh, that was a tough one. Okay, questions? Everybody is in shock or they got it. Uh-oh. All right, maybe we'll come back to one of these. Does it shake it up much? Was anybody's much different than the one I just did? Sometimes when you do another one, let's do this one. So this was A, B, C, D, E, F, no F, G, H, I. Ooh, I got it right. And then if I do get a similar question, it's a little bit different. Okay, so things get shuffled. All right. Anybody want to try one of those again in a little while? Or you're like, no, I've had enough of that. Okay, I got one thumb. And I've got a yes. Okay, we will come back. I'll put a little note here, do number 4 again. Number 4 again. Let's try something else in the meantime. Let's see, what else was fun? So those are the only 2 requests I have so far. Let's see, undo this one. So this one, you just kind of check off which of the regions we have. When I split a universe up into, this should have a checkbox outside, but it doesn't. I guess it doesn't need one. When you take a universe and split it up with 3 sets, you get a potentially 1 outside, 2, 3, 4, 5, 6, 7, 8 disjoint regions. Here they wanted us to select all of the regions that represent a student doing history or statistics or English. So or is the union, which pretty much means everything for this one. And I do a similar question, ooh, or but not. Ooh, that's a good one. I like that one. All right, let's try this one. And actually, I'm going to copy this into my notebook because this one's harder. New page, please. All right, there we go. So the way I would write this with like the symbol notation would be, let's use, we could abbreviate these as S, E, and H if you don't mind. So this would be take the set S, or would be union with set E, but not means the same thing as and the complement. So that would be and H complement. So that means I want to take everything, so highlighter, everything that's in statistics here, everything that's in English here, so that's that whole figure 8, but then this says and outside of history. So as far as outside history goes, that would mean this stuff out here, but these guys are off limits. So I can't have that because that's in history, that's in history, that's in history. So my answer would be this funky shape out here. So I would say I want this box. Oops, that's a bad symbol. Ah, help, help, stop it. Excuse me, my pen went a little nuts there. I would want this one, and that one. See how I'm going about doing that? Got kind of messy. Let's erase and do it again. Wow, it's a nice big eraser. Okay, fun with digital paper. All right, so again, I want statistics or English. All right, so if I use, let's do the yellow highlighter maybe, is that visible here? So statistics or English is this whole figure 8, like that. But then they say, but not history. So then I have to modify to say, oh, look out there instead, and erase that part right there. So the answer would be this stuff up here. 1, 2, 3 check boxes. All right. So hopefully that was fun and educational. Boom, boom, boom. Oh, I should probably do submit. Yay. All right, what else was fun? This is actually a pretty good one. We could do one of these together. Number 6, 7. Probably draw a picture on that one. There's another picture one. Okay, so those are all pretty similar to each other. Ooh, and then that's a complicated one right there. All right, let's go back up to that one, volleyball one. Okay, we're gonna try to do this one together. So first I want the text. And new page. This is kind of like that blood type one I want to go over to shortly. Pointer. Come on. Oh, this is being difficult. Oh, there we go. Sometimes copying from one place to another is harder than it looks. All right, we're just going to go with that. Okay, so suppose a group of 77 college students. Okay, so just going to take some notes as I go here. The number of things in my universe is 77. That's up here. Whether they play volleyball, soccer, or basketball. Did they play in high school? Of those, 12 students played only, let's see, 12 students played only 12, of those 12 only, why can't I read that right? Of those students, there we go, 12 only played volleyball, 8 only played soccer, 9 only played basketball, 10 played volleyball, soccer. Okay, we need that Venn diagram now. Okay, so let's get that picture in here. I can take some notes without it. Okay, so here is my universe with sets, and I can kind of fit it right there. All right, so let's see. Let's pick on 12 here. Of those students, 12 only played volleyball. So that means they were up here because they didn't also play soccer or basketball. So I think there's a 12 right there. 8 only played soccer. So I think that's right here. They played soccer, but not volleyball or basketball. 9 only played basketball. So then 9 should go there. All right, so I got 12, I got 8 accounted for, I got 9 accounted for. 10 played both volleyball and soccer. Okay, so 10 played volleyball and soccer. Uh-oh. It doesn't say they played only volleyball and soccer. Right, you see the word only is missing there, is that important? So is that 10 go here, or is 10 in this whole region right here? Interesting. I'm leaning toward that. 6 played basketball and volleyball. So then 6, basketball and volleyball would be this region over here. I'm going to need a new color. So I think, oops, that's not a new color. There we go. So I think this right here, those 2 boxes is the 6. 18 played soccer and basketball. Another color. So soccer and basketball is this region. So I think that is, where did it go? 18. 11 played all 3. Ooh, that can't possibly work out. So I think they worded this problem badly. I think it should say 10 played only volleyball and soccer. 6 played only basketball and volleyball. 18 played only. If that wasn't the case, I have a problem right here. If they claim 11 is there, but 6 is the total in this region, then that's a problem because I can't put a negative number here. So I think this was just not worded well. I will write to the person who wrote the problem and ask them. Yeah, so I think it's got to be like that. So instead of both, I think that should be only or only both. Only both sounds weird, which means that 10 right there really goes here. That 6 right there really goes there. And what am I missing? Oh, down here, the 18 really goes right there. Okay, so fill in the Venn diagram with the given information. Each number of the Venn diagram represents the count within the smallest enclosed region that contains the number. Okay, got it? All right, so then is there anyone in the universe of 77 college students that didn't play volleyball, soccer, or basketball? One would think so. So to check that, we have to add up all these disjoint regions. So what is 12 plus 10 plus 11 plus 6 plus 18 plus 8 plus 9? Let's see, when we add those up, we get 2, 3, 9, 17, so 7, 8 is 15, 5 and 9 is 14, 1, 2, carry 3, 4, 5, 6, 7. I get 74, which means there should be 3 students that didn't play volleyball, soccer, and basketball. That looks reasonable. So wording matters on these as to which region we're pointing at. And the symbols are much more straightforward than English language. English language makes things way more complicated, unfortunately. Like not having the word only here matters, I think. Okay, so that's the solution to that one. I am going to pause the video here.